Hey everyone, so I'm going to dive right into this first problem here. We have a an equation with radicals in it, and we have the radical, I'm going to fix my microphone here, sorry. We have the radical sign on both sides. So ideally we isolate the radical and square both sides and then continue with algebra to solve for x. But here, this one's a little bit trickier because we have a constant here. We have this -1 hanging out on the right-hand side. That would be this little guy right here. So we could actually technically square both sides as it is, meaning we could go ahead and say, okay, well, we'll square this and square that, right? That's appropriate. I would give a hint though, and if you have a constant attached to a radical, and you have more than one radical involved, make sure the constant is attached to the simpler of the two radicals. Meaning, if I look at the radical on the left, it's pretty simple. It's x plus 2. Though on the right-hand side, I have a coefficient in front of that x. I have a 2x minus 1. It's a little more complex. I get a little weary there. I'm going to go ahead and add 1 to both sides. And I'm going to then square both sides from there. And I'm going to show you where I made a mistake. I ran through this video and I made a mistake. I'm going to show you where I made it. It's a common mistake. But anyway, here we go. So we're going to square both sides here. Now don't forget that this is actually, if we expand that expression out on the left, that we're actually foiling this, and don't forget your middle term here. This will not ultimately end up being x plus 2 plus 1. We do have a middle term in there. So I'm going to go ahead and just keep this in mind. We're using FOIL, right? So we're doing first outer, and then inner, and then last. So we'll start off with x plus 2, because that is square root of x plus 2 times square root of x plus 2 is x plus 2. Then we end up with as our middle term. So we actually have 2 of those square root x plus 2's that we're going to add together in the middle, and then we have our plus 1. That's our 1 times 1. And then on the right hand side, pretty clean, when we take the square root of 2x minus 1 and square it, we have just simply 2x plus 1. Now remember, the premise is when you square something that's square rooted, you're just dropping the radical, right? They're opposite operations. So they basically undo themselves, and you're just left with 2x minus 1. So what we end up with on the left-hand side is I'm going to have I combine those two like terms. Now I need to do some further cleanup here. I need to clean up the left, and I need to isolate that square root again. So my goal is to actually take this square root, right? And I just need to have it be by itself again. And I can do that. I just need to do a few more maneuvers. So I will go ahead and subtract x and 3 from both sides. Almost there. Okay. And then before we go any further, get rid of that 2 coefficient there by dividing both sides by 2. And voila. Okay. And we can, of course, square both sides again. No biggie. Now, yep, see, this is where I need to get rid of this. I had a math moment. When we take x plus 2 on the left, and then we'll square the top and the bottom. If we FOIL out the top, we'll have x squared minus 8x plus 16. And you put a minus 16. Oh, bad. Yeah, I had a minus 16 right there, and it was messing me up. Really messing me up here. Almost done. So we could, I like to get rid of that 4 on the bottom. I'll just simply cross multiply and then see what shakes that out. Now remember, we have a quadratic here that we do need to solve at this point when we want to find x. So our goal is to combine all the terms on both sides. And that means you're moving the 4x and the 2 over. And that's not a 2, that's an 8. I'm sorry. 8. Yeah, there we go. 8. Don't watch that distribution, right? Okay. So ultimately we end up with, I'm going to bleed over into the next problem. So we have x squared minus 12x plus 8. Okay, so I don't see any factors of 8 that'll give us minus 12, but we could do the quadratic formula real quick. So I'm going to do that off to the right. Go ahead and just leave myself some space and go to the right. So to do that, okay, we'll have x equals negative b is positive 12 plus or minus b squared is 144 minus 4 times 1 times 8 all over 2 times a. All right, so 12 plus or minus 144 minus 32 over 2. Yeah, it's clearly not, this is not factorable, but 144 minus 32 is 112. And I think, okay, I think, yeah, it's divisible by 16. So ultimately we have 12 plus or minus root 16 times root 7. I'm breaking up the root 112 into 16 times 7. 16 times 7 is 112. And then we'll have 2. Now I know root 16 is 4, so I'm getting closer here. 4 root 7 over 2. All right, and if we reduce everything by 2, 2, 2, 2, we'll have 6 and 2. So, wow. 2 root 7. All right, so ultimately I have 6 plus or minus 2 root 7. Now, a lot of times when we're doing these, they do end up being factorable. I'm sorry, I just went ahead and went through some old problems here, but this is how you would do the first problem. Okay, so going back real quick, you just have to analyze, okay, well, I have 2 radicals on both sides, one on each side. What's the best way to start? I went ahead and moved the 1 over to be with the more simple radical and start squaring away. So basically you square both sides and then you clean things up and then try to isolate. Usually there's one more radical left that you need to isolate and then square. And then we just ended up with, sadly, sort of a more difficult quadratic to solve for here. But hopefully that helps for this particular problem. We're going to move on to a couple more radicals and then move on to a different topic. Thank you.